Welcome back, students. In this particular video we will study implementation of full adder using half adders. And before watching this video, I am hopeful that you must have already studied and watched the video of full adder implementation. If you haven't, then please refer to that video before watching this particular video. Now what have we seen in the earlier class? If we talk about the equation of sum, it was equal to x XOR y XOR z, and carry equation we got last time, it was like xy plus yz plus zx. But if you will see the last video, you must have seen that once we have shown the logic diagram, it was containing lot of independent AND gates, 3 input AND gates, 2 input AND gates, and lot of gates were used. In order to remove that limitation, we are using half adders in an efficient way so that a good hardware implementation diagram can be used for implementing full adder. For that, we need a small modification in the equation of carry. Now, as far as the equation of sum is concerned, we will stick with the same equation that we received last time while solving. But the carry equation, we will have an alternate form of the equation, and that equation we will calculate using Boolean algebra method. And already you know how to do it. We can write carry will be equal to wherever the value is 1 and their corresponding values in terms of x, y, z. So we will write first one x bar yz, then we are having these three values. So first one is 101, which is x y bar z, 110, which is x y z bar, and 111, which will be x y and z. So these are the four variables, four terms here. Now again you will see if something is common. If we will look into these two, we can take z common. It will be x bar y plus x y bar into z, and if we see these two, we can take x y common. It will be z bar plus z. So it will be equal to, again if we look at this, it is a behavior of XOR gate, x bar y plus x y bar. So we can write it in the form of x XOR y dot z. Then z bar plus z, as per the Boolean algebra, it is always equal to 1. Very logical this is, because both are complements of each other, and if z value is 0, then z bar has to be 1, and if z is 1, then z bar has to be 0. So any of them has to be 1. So obviously once, and if z is 1, then z bar has to be 0. It means in both the cases, while we are adding the two values, it will be like 1 plus 0 or 0 plus 1. It is always equal to 1. So that's why z bar plus z is 1. So we can simplify and we can write carry out equation is nothing but x XOR y dot z plus xy. So this is also the carry out equation, and the equation we got last time, this is also correct. Now based on the equations we are having regarding sum and the carry, we will have one alternate diagram. Let us see that in our next slide. Now students, you can see the diagram, and it has been shown here also how this is implementing our full adder and how many half adders we are using for it. The answer is 2. This is one set of half adder, this is the another set of half adder, and half adder we have covered in our previous videos. We have read that half adder logic diagram is nothing but XOR gate and an AND gate, right, with two inputs like this. So that particular setup is being used here and here also. Now very quickly we will see how this diagram is implementing our equations, which I will again write for you. Sum was x XOR y XOR z, and carry we got was x XOR y dot z plus xy. So you can see this is x XOR y we are getting from two inputs, and z input we are giving from here to the XOR gate. This is x XOR y coming. So finally we are getting here x XOR y XOR z. So sum we have verified, right? Now come to the carry. In carry we are having two terms. This is term 1, this is term 2, and ultimately T1 and T2 is being added. Added means it is being odd. Let us see how are we getting both the terms. So if you will see here, this x and y input, this is my x, this is y, so this product is xy, so we are getting term 1. Then second term is what? X XOR y dot z. So please note down, this line is x XOR y, so we are taking connection from here only, so obviously this connection is x XOR y, and from this z we are taking here one connection which is z. So then we are doing dot product of these two inputs, so it is obviously x XOR y is as one input, next input is z, so we are getting x XOR y dot z, which is my term 2. Ultimately what are we doing? OR operation of T1 and T2. So this is my T2, this is my T1, so both the inputs, what we are doing, both the outputs, sorry, we are doing OR operation, and ultimately what we are getting is exact equation of carry. So this is the efficient way of implementing full adder using half adders. If you are having any questions, any doubts regarding this, do ask in the comment section. In our next video, we will talk about half subtractors. So thank you all and have a nice time.